In this part, we're going to be discussing the family Enterobactericeae, and you can tell from the name that these are bacteria that are found in the enteric system or in the intestine and in the colon. They are gram-negative bacteria. They are non-spore-forming rods, and some of them actually live normally within our bowels, for example, E. coli, but they can become pathogenic, while others are not part of the normal microbiome. So we'll talk about a little bit about each. These are the ones that are of clinical importance, and I kind of highlighted the three that we'll be discussing. There is E. coli. It is a coliform enteric bacteria. Coliform means that it is part of the normal microbiome. Salmonella and Shigella are non-coliform enteric bacteria, meaning that they are not part of the normal microbiome. So the presence of Salmonella and Shigella would lead to disease, so they are true human pathogens. Other examples, but we won't be discussing them, are in detail. There are Klebsiella, Enterobacter, Serratia, Proteus, and Citrobacter. So the key characteristics about all of these, what do they have in common, is that they are all oxidase negative, meaning that they are anaerobic. They have flagella, and in order to diagnose them, we need enriched, selective, and differential media. The virulence factors and the antigenic factors that are found in these bacteria are pretty complex. So there are different antigens that could trigger an immune response here. So there is the flagella. The flagellar antigen is known as the H antigen. There is a capsule that is known as the K antigen. And then there is the somatic or the cell wall antigen that is known as the O antigen. And that again is the lipopolysaccharide. And we'll see that some of these, that they also secrete an enterotoxin. Enterotoxin means that they are toxic to the intestine. Okay, and therefore they're responsible for diarrhea. Now, the H and K antigens are not found on all of them or on all of the species, but they absolutely all have that O antigen. That's why it's underlined. And the O antigen can lead to endotoxic shock. Remember the O antigen, again, that's the lipopolysaccharide that are found in these gram-negative bacteria. Here you can see a breakdown of these antigens. So again, the flagella, that's the H antigen, the capsule, that's the K antigen, and the somatic found in the cell wall of the lipopolysaccharides, that's the O antigen. Remember that O antigen is found in all of them, while K and H antigen is found in most of them, but not all. Okay. Now, which of the following is true of the enterics? Some are normal flora, some release an endotoxin, some release an enterotoxin, or all of the above are true. So if you answered that all of the above are true, that is correct. So some of them are part of the normal flora, like E. coli. Some do release endotoxin, and that is the O antigen. Some release enterotoxins, and these are usually exotoxins that will lead to diarrhea. So again, all of the above are true statements about the enterics. So let's discuss E. coli first. It is the most common non-fastidious bacterium in the gut. There are about 150 strains. Some are pathogenic, others are not. So we're going to talk about the pathogenic ones. The pathogenic ones are divided into two groups. There's an enterotoxigenic and an enterohemorrhagic. The enterotoxigenic, or the ETEC, those lead to, they secrete an exotoxin that leads to diarrhea. Okay, so that exotoxin will stimulate secretions by the intestine, leading to a lot of fluid loss because of, leading to that diarrhea. And that toxin, the bacteria, sometimes the toxin can be destroyed by heat. These are called heat labile toxin, while others, well, sometimes that exotoxin cannot be destroyed by heat, and that's called a heat stable toxin. Now, the enterohemorrhagic E. coli, or the EHECs, the exotoxin produced by these strains leads to the inflammation of the colon and bleeding. Okay, so that is called an hemorrhagic colitis. Sometimes that toxin is absorbed by the intestine and gets to the kidneys, leading to what is known as hemolytic uremic syndrome. It could eventually lead to kidney damage. Okay, so some clinical cases of E. coli. E. coli is usually almost always transferred or transmitted among humans. Um, Pathogenic strains are a very common reason for diarrhea in infants, and it could cause mortality among these babies. We see that E. coli is the most common cause of travelers' diarrhea, meaning going to areas where E. coli is endemic, they develop diarrhea. And again, for most cases, it is due to E. coli infections. It can also lead to UTIs. So, about 50 to 80% of UTIs are caused by E. coli. So, how do we manage E. coli infections? Well, we could manage it with over the counter preparations like loperamide. Loperamide is an anticholinergic, meaning that it um, slows down, it will slow down the intestinal motility, okay, to kind of um, slow down that diarrhea. Okay, so it slows down that gut motility, but a disadvantage of that is that it will keep the E. coli inside of the body. Okay, so we do really want to flush the E. coli out of the body. Um, the best treatment for it is actually Pepto-Bismol. Okay, it's very effective. It is an antimicrobial um, agent that will kill the microbe. Okay, but we don't give antibiotics. Okay, so my antimicrobial is a little bit different than an antibiotic. We don't give antibiotics to treat E. coli infections for several reasons. One of them is that the antibiotic will kill E. coli along with the good bacteria. Okay, so we want to keep that balance where the good bacteria will compete with E. coli, but if you kill both of them, we kind of, E. coli might still be able to survive because you've killed the good bacteria. It was also found that giving antibiotics in E. coli infections um, might lead to the spread of the exotoxin, the hemorrhagic exotoxin, and could eventually lead to kidney failure. Okay, so a little bit on the history of E. coli and food infections. E. coli, so that you know, are divided according to their somatic, the O antigen, and to the H, or the flagellar antigen. So when you see this O157H7, know that they are classified according to these different antigens. Okay, so they have this kind of E. coli has the O antigen type 157 and the H antigen type 7. It is an enterohemorrhagic stain that was involved in infections from fast food hamburgers in 1982. Um, it was McDonald's. Okay, just another reason, not to eat it. And then it was found when tracking the source of the E. coli infection was found to, it was the cattle intestine. Okay, so obviously they weren't disinfected properly, and then they ended up in these burgers, and people got sick from it. Okay, unfortunately, this did not lead to proper preparation of meat and poultry. There's actually the U.S. Department of Agriculture requires that all fresh meat and poultry products have a warning label that it is really the consumer's responsibility that they handle, that they treat, they cook it thoroughly. Okay, so they kind of threw that responsibility back to the consumer as opposed to them being responsible for checking all of the commercial meat. Okay, so testing commercial meat is really done at random. Not every single piece of meat that is out there that is being sold is has been checked for E. coli or for other infections. And again, that responsibility is basically up to the consumer. Now we'll discuss these non-coliform enterics. So the non-coliform enterics, we said that these are enterics that are not part of the normal human microbiome. So they are considered true human pathogens. And what they have in common is that they do not ferment lactose. Okay, so E. coli, that was a coliform, and it was lactose positive, while these are non coliform and they're lactose negative. And a good way to remember is that these enterics, non coliform, so not part of the microbiome, they are lactose intolerant, sorry, lactose negative, meaning that they do not ferment lactose. Okay, so they are not a lot of things. They are not part of the microbiome and they do not ferment lactose. And these are, again, Salmonella and Shigella. They are true pathogens because they aren't part of the microbiome. Okay, so let's talk about if we get infections by these, they will lead to diseases, diarrhea. Most of the time, though, there are other symptoms with the diarrhea. So let's take a look at Salmonella first. It leads to a disease called typhoid fever. It's caused by Salmonella typhi. It is due to the ingested of contaminated food or water, and the infection happens through the fecal oral route, meaning that somebody who is shedding this bacteria in their feces, and then later on they had to prepare food without properly washing their hands first, and that food is now contaminated and somebody ate it and so on, they got infected. Another source of the infection could be cold-blooded animals like reptiles. So if a person has a turtle or an iguana, these tend to be carriers of Salmonella typhi and they can transmit it over to their humans. Other asymptomatic carriers are food handlers, where the bacteria is hiding in their gallbladder and they tend to shed that bacteria, again, in their feces, not wash their hands properly, they handle food, and they transmit that to their whoever eats the food. Okay, so now these bacilli, they stick to the small intestine. They lead to this very invasive diarrhea. Okay, severe diarrhea could leads to dehydration and sometimes can even lead to septicemia and shock. The treatment is antibiotics. Okay, there are vaccines that are available. It's not given to everybody. It's just reserved for those who are either traveling to endemic areas, or they have to handle these cold-blooded animals, or they're on a daily basis. Okay, so it's not one of those vaccines that are recommended for everybody. Here you can see the typhoid. Okay, here you can see up here, that's the typhoid bacillus, and it's invading the the villi of the intestine. Eventually, due to the toxins, it leads to these ulcers, and sometimes these ulcers can perforate. Here you can see all the redness. You can see some of the ulcers here. Now, Shigella leads to what is known as shigellosis or bacillary dysentery. The signs and symptoms are this very incapacitating dysentery. So dysentery basically means diarrhea with bleeding, with severe abdominal cramps, and sometimes it just keeps on going. even if the patient isn't actually passing anything through their bowels, they still have these cramps. They still have the feeling that they need to empty their bowels, but no matter how much they go to the bathroom, there's really nothing passing through. Um, but if there is anything passing through, there is blood in their stools or in the feces. It's bloody and full of mucus. And that again, collectively, all of these signs and symptoms are known as dysentery. Okay, the common causes, so there, all of these are different types of Shigella. So there's Shigella dysentery, Shigella sonnei, flexneri, and boydii, just different kinds of Shigella. They get into the intestine through Peyer's patches. So if you guys remember Peyer's patches, which are collections of lymphatic nodules that are found mostly in the terminal ileum of the small intestine, and they are responsible for filtering out bacteria. Okay, well, obviously they have failed here because, again, Shigella is not part of the normal microbiome. Most of the time, this is the very first time that a person is being exposed to these. And if it is if there's a high load of bacteria, the Peyer's patches really cannot do much about it. Okay, and these Shigella release endotoxins and exotoxins that lead to that very incapacitating dysentery. Now, treatment would be antibiotics and fluid replacement to prevent dehydration. Here you can see the effect in the colon. So there's a lot of redness, ulceration, lots of bleeding, and um, because of the irritation, there's going to be lots of mucus as well. So let's check, make sure we're all on the same page here. If your nephew gets gastroenteritis after cleaning out his pet snake's aquarium, so what is the most likely cause of the infection? Is it Shigella? Is it pneumococci? Is it E. coli? Is it salmonella? So if you've answered salmonella, then you are correct. And this is the end of this